Welcome back. Now in this tutorial, let us develop algorithms for the NQ and DQ operation for FIFO queue using one-dimensional array. NQ is the operation that adds a new element to the rear end of the queue, and DQ is the operation that deletes the element from the front end of the queue. In order to maintain the queue, we need two integer markers, rear and the front. Rear is the integer variable to hold the index of the rear end of the queue, that is the index of the next insertion element, and front is the integer variable to hold the index of the front end of the queue, that is the index of the next element to be deleted from the queue. You can see that I have described these two variables here. And we need one-dimensional array, so item is the one-dimensional array with the length size. That means size is the number of elements in the item array. We are considering a fixed kind of array for this algorithm. For practical implementation, we can consider a dynamic kind of array, and we can increase the size of the array if overflow happens. So initially we are placing both the rear and front at the 0th index. That means at the very first element of the array. So the array is empty and we are placing rear and front at the 0th element, and they are having the same value. So if that happens again, that means if the rear and front are equal, then that is the condition for underflow checking. You can just see this. The initial condition is the underflow condition because initially the array is empty and we are having the rear and front at the very beginning of the array where they are having the same value. So later on, if rear and front are having the same value again, then that's the condition for the underflow. The overflow will happen if the rear index goes beyond the last element. Our NQ operation logic is very simple. We'll be placing the new element at the rear index, that means where the rear is right now, and then we'll be moving the rear to the next element. So if the rear goes beyond the last element, that means we have inserted the new element in the last index. So we do not have any provision for insertion of new element then. So the overflow will happen. So the overflow will happen only if the rear is beyond the last element. That means if the rear equals with the size. Okay, let us move ahead and try to write the algorithms. Okay, I'll write the NQ operation first, and it's going to receive a value v that we will be inserting into the queue. First of all, we need to check if the array is overflow, if the queue is overflow or not. So if the rear is actually at size, that means beyond the last element, then it's overflow. So we'll be printing the message there, and we'll exit the NQ operation because the insertion is not possible since the queue is overflow. So that's the end if, and this if will check if overflow is there for the queue or not, and will discard the NQ operation. Now if the queue is not in overflow state, then we can place the new element at the rear index. So item is the array, and at the rear what we are doing, we are placing the new value v, and then we need to move the rear to the next element so that if someone calls the NQ operation once more, then the new element could be inserted at the rear. So we are moving the rear to the next element, rear plus 1. So that's the insertion operation. It's straightforward. Now let us write the DQ operation. DQ operation is going to delete the element at the front of the queue so that we can get first in, first out order. So first of all, what we need to check is that whether the queue is empty or not, if the queue is underflow or not, and that will happen if the rear and front are having the same value. In that case, we'll be printing queue underflow, and we'll exit the DQ operation. Otherwise, we can pick up the value from the front. So v is, item is the array, and we are picking up the value from the front index, and then we'll be moving the front to the next element so that if DQ is called once more, then we can pick up the value from the next element. And we need to return the value that we deleted from the front. So that's the DQ operation. Okay, in the next tutorial, I will try run these NQ and DQ operation and we'll see how they works. Thank you for watching.